Good morning, students. So we'll continue the lecture number 26, that is the concept of node analysis. So the node analysis says that in a circuit diagram given, if you mention n number of nodes, so we will get the n minus 1 equations to solve. And the one more factor is that in that we have to make the 1 as the reference node, that is grounded. Then next point is most connected branches taken as the reference node. So this is one important factor for making a reference node. Then all outgoing currents are taken as positive and all incoming currents are taken as negative. Then one more point is the nodes which we define, apart from reference node, all nodes are at the higher potential compared to the reference node. So here we have one example, a simple example, that one circuit diagram having the VA and VB are the voltage sources, then R1, R2, R3, R4, R5 are the resistors. So in this I will mention these three nodes here, node 1, node 2 and node 3, and I will make the node 3 as the reference node. Then I will define the voltages, that is V1 at this node and V2 at this node. Then what are the equations we are going to get? So if I apply KCL, to node number 1, KCL to node 1, the equations I am getting as V1 minus VA divided by the resistor R1, then plus V1 divided by R4 plus V1 minus V2 divided by R2 is equal to 0. This is the one equation. Then if I apply KCL to node 2, that is V2 minus VB divided by R3 plus V2 divided by R5 plus V2 minus V1 divided by R2. So this is equal to 0. These two. So we have VA and VB. So these are the constant. So we can solve for V1 and V2 from these two equations, 1 and 2. So this is the simple analysis of the node. Then if I take one problem, so the problem is like this. So this current is given and resistor value 4, 2, 3, this voltage is 55. So what is the power, or how much power the 2A source extracts? Power at 2A is the question. So here there are two nodes, so I will define this node as the reference node. Then direction of current is like this, so this is the direction, so this becomes the positive, negative. Okay, so then this point I'll make it as V1. Okay, so these are the directions of the current. So what is the first equation we will get? The first equation with respect to V1, this is in opposite directions to V1, so this is minus 55 divided by, then what is the total resistance? 3 plus 2, this is 5, then plus V1 divided by 4 plus the current is 2, this is equal to 0. Okay, then what value you are going to get here? This is, if I simplify, this is 4V1 minus 220 plus 5V1 plus 40 is equal to 0. So this is 9V1 equal to 180. So V1 equal to 20 volts. Okay, so this value we got. Okay, with only one equation. There are two nodes, so we got only one equation, that is n minus 1 equation, and got the value. Then what is the power? Power at 2A. So this is nothing but V into I. So V we have calculated. What is the V? That is 20 into current is 2. So it is 40 watts. So this is nothing but 40 watts is absorbed. 40 watt is absorbed. Okay. So like this you have to solve the problems. Okay. Next one is, that is, find power delivered by dependent voltage source, and circuit diagram is given. So first I will define the reference voltages, reference node. So this node I will make it as a reference node. Then here I will define it as V1 as the voltage. So first you can write what is IA from this. What is IA? IA is nothing but what? V1 divided by 50. So first point is IA. It is nothing but V1 divided by 50. From the circuit diagram you can write. Then we will apply for KCL at the node V1. So V1 minus 80 divided by 5 plus V1 divided by 50 plus V1. So it is in the same direction. So V1 minus of minus becomes plus, that is 75 IA divided by 25. Okay, this is equal to 0. Okay, next, so it will reduce to what? V1 minus 80 divided by 5 plus V1 divided by 50 plus, so it is if you substitute IA equal to V1 divided by 50, so it will reduces to 5 into V1 divided by 50 equal to 0. So if you take LCM and make the equations, so it will become what? 10 into V1 minus 800 plus V1 plus 5V1 equal to 0. So we get V1 is equal to 50. Okay, V1 equal to 50 we are going to get. So then what is IA? IA is equal to V1 by 50. So this is nothing but 1 amperes. Then what is I1 from the diagram? What can you write? I1 equal to potential difference between this and this divided by the resistance values. So I1 is equal to V1 plus 75 IA divided by 25. So this is equal to, if you substitute all the values, V1 is 50, then 75 into 1 ampere, so divided by 50, 125 divided by 25, so it will get as 5 amperes. So what is power? Power is at 75 IA is equal to what? V into I. V is nothing but what? 75 into IA into current, that is I1. So it is 75 into IA is 1, 75 into 5. So this is 375 ohms. This we get as 375 watts, but the sign is negative because it is supplied. Okay, the sign is negative because it is supplied. It is supplied. Okay, so this is about the node analysis. So thank you.